Hi everyone, so now we're going to be talking about properties of sets. And this is something that hopefully you've been wondering about because it seems that sets and lists do the same thing, right? They both just keep track of multiple elements. However, as we'll see, there are a bunch of different properties of sets that make them useful in different situations than when lists would be useful. Now, before we talk about the actual properties of the sets, let's take a look at how sets are actually made so that we can better understand how these properties arise. So, the first thing, before we actually go into how the sets are made, is that we need to have a discussion about hash functions. Now, hash functions are a general term in computer science, and they refer to when we take a function which basically takes a value, any sort of value, like it could be a string, it could be an integer, it could be a float, and essentially returns an integer instead. So what you can think of them is that if I give it a bunch of different values, the best hash function in the world would give me a unique integer for each of those values. So let's see how Python's built-in hash function, which is just hash, actually works. So let's say I do hash of 42. So Python, whenever you give it an integer, just hashes it to that integer. So 42 returns hash 42. However, let's say that I do hash of hello. So this is a string, however when I hash it, I get this long number. Now, we're not going to care about what the actual output is, but the key to note is, let's say that I do hash of hello1. Since hello1 is different than hello, I expect to get a different value. And in this case, yep, I got a completely different value, which, as it should be, Python's hash function works pretty well. So, now let's look at the actual implementation of sets, and we'll get back to the hash function in a second. So, sets are made of buckets. Now, the way that you can think about it is that a set basically has a bunch of buckets under the hood, where every time we put an element into it, it basically puts it into a bucket. Now, the way that it decides which bucket to put the element in is exactly with the hash function. So why don't we do a few examples of adding elements to this set that we made with 4 buckets. So the first element we want to add is hello. Now what Python does when we say add hello is it basically does hash of hello. And so let's see what that outputs. Hash hello. We get this number. Then what it does is this number on its own isn't that useful. We want it to basically tell us which bucket to put it in. So we need a number between 0 and 4, not including 4. So what it does is it mods it by the number of buckets, which in this case is 4. And so when we mod what we just got by 4, we get 0. So essentially what just happens is that we put hello into the bucket 0. Now it's important to note that there can be more than one element in the bucket. So in this situation, hello goes into 0. Now let's say what happens when we add world into our bucket. So we do the same exact thing in the case of hello. We basically hash world. So let's see what that does. Hash world. We get this long number. Then we mod it by 4 with the number of buckets. And we get 2. So, as you might expect, we now put world into the second bucket. Okay, great. And now finally, we're going to do hash of 42. As we just saw, that returns 42. Then we mod it by the number of buckets, and we get 2. So, once again, we put something into bucket 2, so now there's a 42 in this bucket. So, as you can see, Python basically uses this hash value to decide where the element goes into its bucket. This will be really important in understanding how this model works right now when we look at the properties of sets. So the first property of sets is that sets are unordered. Now, let's see examples of this working. So let's say that I make a set S equals the set containing hello, world, 42. Now, I put them in the order hello, then world, then 42. However, let's say I do print s. It once again comes out as hello, world, 42. However, let's say I did hello, world, rohan, 42. And now I printed s. Notice how it did hello, then rohan, then world, even though I put it in the order hello, world, and rohan. And this is pretty obvious when we think about how the set is actually implemented. It's not like the hash function says that hello should go before the bucket that world is in. So basically everything just goes in whatever bucket that it goes in, and then when we print it out, it basically just takes them out of the bucket in any order. So if we wanted to prove this more thoroughly, we could say, let's ask, is the set 1, 2, 3 equal to the set containing 3, 2, 1? And the answer is true, because sets only care about the elements inside of them, not actually the order of them. The next thing to know about sets is that elements inside of sets are unique. So let's look at this example. We create the set 2, 2, 2. However, when we print s, notice how it's only the list containing 2. And then we print the length of s, and it's only 1. This is, once again, if we look at our model with the buckets, because when we put an element into a bucket, we only put it that one element. Sets only keep track of a single value. So we can put as many of the same element as we want, but it'll only keep track of one. The next property is that elements inside of a set must be mutable. Now, this property might seem a little arbitrary at first, but let's look at this example. So we make the list A, and lists, as we know, are mutable. However, when we try to make a list containing, or a set containing A, it gives us this error, that unhashable type list. Now, in order to understand why this is the error, let's see what happens when we try to hash a list. 1, 2, 3. So this is what happened. It said unhashable type list. So we should understand by now why this would happen, right? Why is it that when I try to make a set, it tells me unhashable type list? Because what Python did is that it took this list A, it then tried to hash it to figure out what bucket to put in, however then it crashed because it can't hash the list. So the reason that this is because let's say that we can put lists inside of sets. Then, so I create the set S with list A. Then what if I did A of 1 is equal to 42? Now presumably when I hash the list A, because the value inside of A is different, now there's a 42 instead of the word R, the hash function would return a different value, which means that when I go to see if the list A is in that bucket, I would go to a different bucket because the hash value is changed. So this is why Python does not allow mutable values inside of sets. And finally, let's look, or actually one more example. So this is interesting, but basically it's good to note that sets themselves are mutable values. So if I tried to make a set containing a set, that also would crash for the same reasons as we explained just a moment earlier. Now the final thing that we're going to talk about in terms of the properties of sets is that sets are extremely efficient. Now let's look at this example. Not this example. This example. Good. So essentially what this function is doing is that it's making a set of size 1000 and a list of size 1000, and it's checking if all the numbers from 0 to 1000 are inside of that list. So when we used a list, it took us 2 seconds. However, when we used a set, checking if all those elements are inside of it took a mere 0.07 seconds. Now the key is this operator right here. If X is in A. Now, imagine for a list, if I wanted to check if an element is in a list, then the only way that I can do it is basically just start at the beginning of the list and keep marching until I find that element. However, oftentimes I would have to look at least at half of the elements, and later on we'll talk about a better way to analyze this. However, with a set, let's say in this example, I wanted to check if 42 is in S. Now, I don't have to look through any elements. All that the Python will do is basically hash 42, mod it by 4, and then go to bucket 2 and say, okay, 42 is in bucket 2. Now let's say that I wanted to check if dog is in S. Now Python would hash dog and mod it. Let's say that that returns 3. Then it will go to bucket 3 and realize dog isn't there and return false. However, notice that in all of these operations, we just hash it and go directly to the bucket. So this is why, when we check if something is inside of a set, it runs very much faster than if we check if something is inside of a list. So once again, we see another property of sets, or the key property of sets, which is why we would prefer using them over lists. Any situation where we know that we have to continually check if some element has been seen before, or if some element is inside of a set of things, we would rather use a set than a list. So these are some general properties of sets, which are important to note moving forward so that we can decide when to use sets versus when to use lists and other data structures.